Hello everyone, in this video tutorial I am going to explain one continuous beam problem in StatPro. The question is like this: prepare the structural model of the beam as shown in the figure and draw the bending moment and shear force diagram using StatPro. They given one continuous beam which is having two span. The first span of the beam is 3 meter and second span is 3 meter. In the first span, they given one point load that is acting at a distance of 1 meter from left end, and for the second span, they provided one UDL of value 20 kilonewton per meter. Then they given two hinged support and one roller support. So now I am going to explain how to solve this problem using StatPro. I am using Select Series 6 version of StatPro. Here I am going to start with new project. I will start with space type of problem. Then I will name it as beam number 02. Then I will select length unit as meter and force unit as kilonewton. Then I will click on next. Here I will choose add beam type of problem. Then I will click on finish. So by default we can see the grid of 1 meter into 1 meter length. If this grid is not available, I will go for this icon, that is snap node beam option. If I click on that, I will get the grid. So first beam I have to prepare. So whatever the beam that we will consider from support to support. The first beam length, that is 3 meter. So I will start preparing that model. So from 0 to 3 I will create one beam. So we have to make sure that this snap node beam button is in blue color, then only it will snap the points or grids. The second beam is also having a length of 3 meter. So from 3 to 6 I am going to create one more beam. Once it is created, then I will close this window. So if you want to see entire structure, I will go for this icon, that is display whole structure. This is in isometric view. I will go for this icon. So now I can see in the front view. If you want to check the dimension, I can go for this icon, that is dimension. So if you click on display, so it will show the length of each and every beam. If you don't want to see that one, again I will go for dimension option. Then I will go for remove. Then I will click on remove. It will remove the display of dimension. So once I create the model, the next step I have to create the property. So I will go for this icon, that is property page. So I will go for define. I am going to give the property for this beam, that is rectangular property. I will give 0.3 and 0.3 as dimension of the beam. So in feet it is 1 feet into 1 feet. Then I will select concrete as a material. Then click on add. Then close. Now that property is created, I am going to assign on these two beams. So I will go for use cursor to assign option. Then click on assign. Then click on the first beam. Then click on the second beam. Once it is assigned, again click on assigning. Then close. So you can see whatever you provided that property using 3D rendered view option, that is available here. So once I provided property, next step I am going to give the support. I will go for this icon, that is support page next to property page. So if I see in the diagram, the first support, that is hinged support, which is having two reaction, horizontal and vertical. The second support also having two reaction, The third support is roller support, that is having one reaction, that is in vertical direction. In the Stat Pro, I will go for support page. Again, I will show that one. In this, I will go for create option. In that, I will go for fixed butt option. The first support, I am going to create hinged support, which is having two reaction, that is in horizontal and vertical. So whatever I am going to check, I am releasing in that direction. Whatever I am not checking, that is restricted. So I will click on add. So I created that support. I have to assign on first node and second node. So using cursor, I am going to assign. Click on assign, then click here, then click on the second node. Once it is assigned, then click on assigning again. The next support I am going to create, that is roller support. Again, I will click on create and go to fixed butt. In that, I have to restrict in FY direction. Then I will check all other direction. So it is restricted in Y direction. Then click on add. Then select that support, that is support number 2. Using cursor, I am going to assign on the third node. So I assigned all the support. Then I will close this window. Next thing I am going to do, that is applying loading. So I will go to load page. That icon is available here. So under this load case detail, I am going to create one folder. Click on that load case detail, add. Then by the default name, I am going to create one folder. Then click on add, then close. So under this created folder, I am going to create two loading. The first loading, that is 50 kilonewton. From start node, it is active distance of 1 meter. First I am going to show that one. So I will click on this load case 1, then add. So under member load, the first force I am going to create, that is concentrated force, also known as point force. So the value of that force is 50 kilonewton. So it is acting in downward direction. So I will apply that force, that is 50 kilonewton acting in downward direction. In member load, concentrated force, in the under that minus 50. So after that, if I see in the problem, it is acting at a distance of 1 meter from start node. So while creating the member, I created this as first node and second node. For the second beam, this as first node and second. Therefore, from the first node, it is at a distance of 1 meter. Therefore, I have to give this D1 value as 1 meter. Suppose if it is acting exactly on the center, no need to give this D value. But if it is not acting exactly on the center, I have to give from the left hand. Then it is acting in GY direction. Then click on add, then close. So I created first loading, that is point load of 50 kilonewton acting at a distance of 1 meter from start node. Going to assign using cursor, I will click on this option, assign, then click on the first beam. So I can see the loading. It looks like very high value, but that scaling is not proper. To change the scale, right click on the screen, go to label. In that you will get the option scales. So before changing any scale, click on this icon, that is apply immediately, because as I am going to change here, it is updating on the screen. So I applied point force. I will increase the scale here. So I will maintain at around 30. It will give nice look. So I will distributed force also, I will make that as 30, because I will maintain all the scale uniformly. So whatever required you can change, then click on apply, then OK. So to see the load value, so I can go for Shift V as the shortcut, or else if you don't know the shortcut, you can right click on the screen, go to label. Here we will get the option labels. In that, enable that load value. Whatever you want, you can enable here. If you want to see the node numbers and node point, everything you can enable here. Whatever they written in the bracket, that is the shortcut, that is shift to that shortcut we have to use or activate or deactivate. So the next force, that is 20 kilonewton per meter UDL applying on the second beam. In the Stat Pro, under the same folder I am going to create that load. No need to create one more folder, because if I create in the separate folder, whatever the analysis we are doing, that is doing it separately. So later you have to do the combination. For that reason, I will create all the loads under the same folder. So I will click on that folder whichever I created at the beginning, then click on add. Under the same member load, now I am going to create uniform force. That uniform force value is 20 kilonewton per meter. So it is acting on the entire span. So here I am going to create that value is minus 20. It is acting downward, so I taken minus, acting in GY direction. So now in this problem also it is acting on this entire span. I am not going to use this option. Once I given the value, so minus 20 and GY direction, then click on add, then close this window. So I created that load. It is not assigned on the beam. Using cursor I am going to assign. Click on assign, then click on the beam. So I can see the load here. So once I created the loading, next step is analysis. So before doing the analysis, I have to give the command. I have to tell the software that which type of analysis it has to do. So I will go for command analysis. I will click on perform analysis. I want to do everything whatever listed here. I will click on all, then OK. Now I have to do the analysis. Click on analyze, run analysis, then click on save. It will do the analysis. If I get the warning, it is fine. If I get the error, I am not going to get the answer. We got 2 warning, it is fine. So I will go to the post processing mode. Click on done. So I will go to result view option. I will enable automatic scaling and mode shape. Here I want to see shear force and bending moment values. Click on apply, then OK. So by default it is showing deflection of the beam. I can off that icon, that is deflection. So first thing I want to check shear force. For that I will click on this icon, that is shear Y force. So I can see the SFT, that is shear force diagram. So I want to check the bending moment diagram. I will click on MZ. I can see the bending moment diagram. To see these values, I will go to results, view value, then beam result. In that I want value at ends and maximum, shear force value at end and maximum. Click on annotate. It will give the warning. If the diagram is on, then only it is going to show the values on the screen. I will click on OK, then close. Now I can see the shear force value. I will off that one. I can see the bending moment value. So I want to create the report. First I want to activate loading diagram. So I can check the loading. You can do the adjustment like this. I'm going to export this view. In the report folder, I created one folder in JPG format. I want to save loading for the beam 2. You can check the previous video, that link in the description. So beam number 2 loading in the format JPG I saved. The next view I'm going to export, that is shear force diagram. I will off that loading diagram. I'll export this view using this icon. I will change the format JPG. In the SFD, I will change the name as beam number 2. The third view I want BMD, that is MZ, bending in Z moment. So I will export this view. I will change the format JPG, that is BMD beam number 2. I will save this one. So after this I will go to that folder. I want to create one new Word document. So right click, new, Microsoft Word document. I will name it as beam number 2. So I will open that Word document. I will import all the diagram. So I will go to insert option. In that I will go to importing picture option. From this device, in the desktop I saved in the folder report. So B2 loading, I will import that one. I will name it as loading. Then after that I am going to import shear force diagram. I will go to insert picture. From this divide, the second beam SFD. So I will name it as SFD, shear force diagram. I am going to import bending moment diagram. So B2 BMD. I will name this as BMD. So once I completed, I will click on save. Then I will export this view as PDF document. So you can check the report here. So it is having bending moment, shear force and loading diagram. Thanks for watching.